Okay, back when we learned about the addition reactions of alkenes, one of the reactions that we looked at was the anti-Markovnikov addition of HBr. We would get the anti-Markovnikov addition when we did it in the presence of peroxide. Now, at the time, we didn't give a mechanism because it was a radical mechanism, but now that we've talked about radicals, we can go ahead and look at the mechanism for this reaction. So normally when we add HBr to an alkene, it adds with the bromine being added to the more substituted carbon atom, and that's called Markovnikov addition. However, when we do the addition in the presence of peroxides, the halogen, or the bromine specifically, will add to the less substituted carbon, and we get anti-Markovnikov addition. And so the presence of peroxides initiates a radical mechanism, and the different mechanism gives the different selectivity. So the initiation step is the homolytic cleavage of these peroxides. So in the presence of heat, we produce these peroxides. The peroxides can then abstract a hydrogen from the HBr, producing bromine radicals. All right, then in the propagation steps, in the first step, the bromine adds to our alkene, and it produces a radical, right? But the radical is produced on the other carbon, the one that the bromine didn't add to. And so that's why we get the anti-Markovnikov addition, because we would rather have the radical on the more substituted carbon atom rather than the less substituted carbon. So the bromine goes to the less substituted to give us the anti-Markovnikov addition, and then we get the radical on the more substituted carbon. That can then abstract a hydrogen from another HBr, right? That will produce bromine atoms that can continue the chain reaction and gives us our product. So the most common radical in the solution at any given point in the reaction is going to be Br radicals. So the most common termination step would be the coupling of two bromine radicals, but of course the combination of any two radicals would be a termination step. Now, in all the examples that we've done, we always use the anti-Markovnikov addition of HBr. It turns out it doesn't work with HCl or HI. In the case of HI, the first propagation step is not spontaneous. And in the case of HCl, it's the second propagation step that's not spontaneous. So bromine is kind of in the sweet spot, and this is the only one that we can get the anti-Markovnikov addition with. Works with HBr, not HCl or HI. Now, the bromine can attack from either side of the double bond, and so when we create a new chiral center, we will get both stereoisomers. If the original compound was not chiral, then the two stereoisomers will be enantiomers, and we'll get a racemic mixture. If the starting alkene contains another stereocenter somewhere else, then the two compounds that we get would be diastereomers.